one. And we are live. Welcome. What's up, guys?
We're out early again, so we're just gonna kind of shoot the shit for 4 or 5 minutes before we get started. If anybody's got any questions.
I have a question. What is the background, Walker? It looks like Mars or something. Do you remember?
It is. Hold on, let me turn the volume.
Oh yeah, that does kind of look like a terraformed version of Mars.
Yeah, so I'm on a space station.
Oh, that definitely looks like a starship. The way those windows
yeah, so
are.
I'm in immersed. So I'm using. So for those of you guys who don't know, I'm on the road this week, and so I don't have a camera available to me. So in lieu of just putting my picture up there, I've been working. I don't have any. I'm not using external monitors here, so I am using my VR headset to work, so that I can be immersed in my work environment. So this is a background. I work in the observatorium on immersed VR. So that's what you got here.
So I got a question for the community. The 15 of you that have joined right now, what is your favorite part about joining the live stream? What is the value you get from it? Because we're doing something a little bit different today. And Walker was telling me, he's like, you want people to watch, right? So you can't just throw this on me. But we've got it kind of set up where it's an interesting little set. But I want to ask you guys, why do you guys join? What value do you get from it? Thanks, Dan. Yeah, no, it's where we're going to be responding to Mark McMillen's comments. So we're going to kind of go a deeper dive into I don't know. Walker, you want to explain it?
Yeah, so this week, well, let me answer Rafey's question first. So Rafey said, do the hats look good? Did we get hats from Rafey, from his company?
Rafey did ship hats to the Carrollton office, yes.
Oh, I'm on the road, Rafey, so I don't know. I'm in Tampa. So you guys may not know this, but I don't know if I mentioned this before, but I'm not a fan of the cold. And even though I live in Dallas, Texas, it really doesn't get cold in the winter. There is a period of time in February where it gets cold for a couple of weeks. So I have an RV in Tampa, actually in Ruskin. And I came out. Actually, if you guys are watching the national news, there's like in Manatee County in Florida, there's a big toxic leak that might spill out into Tampa Bay. I'm literally 3 miles down the road from that, so that's actually where I'm at. So I have not been in the office to receive the hats. Hey, John, are you in the office today, or are you?
No, I'll be in the office on Thursday, so I can.
So Robbie, I don't know if the hats have been delivered.
I'll check.
But I appreciate you sending them. I'll definitely wear one in the next stream. But I'll be back in the office next week. So for this, so what we decided for this live stream is you guys. So there's a virtual camera inside Immersed that I'm using for this live stream. I was just going to show my picture. Zach said, "Hey, I think it's a good idea to use Immersed." Just so you guys know, like me and our team, we're all testing, working in a virtual environment. I've been doing it nonstop now for like 6 weeks, where I'm basically inside of a virtual workstation all day long. I wear my headset all day long, and it's incredible. I mean, once you get used to it, it's pretty incredible. And I've basically built a couple of virtual control rooms using our simulator. So I have Factory Studio running in a virtual desktop or on its own screen. I've got Ignition running on its own screen. I'm running Grafana on it on its own screen. And I can move the monitors around, and I mean it's pretty cool. I'm going to shoot a couple of videos to show you a virtual control room in VR. So, but anyway, with that, let's get started. So, Zach, do you want to do your
Yeah.
intro and then?
Yeah, sure. Thank you everyone for joining the Industry 4.0 live stream. We're live here every week at Tuesday at noon Central time. Make sure to subscribe, hit the ring, the bell, make sure to hit the like button. All of those are really good for the YouTube algorithm, which helps our content get to more people. We've got a lot of minds that we need to change in this industry in order to save and create middle-class jobs, which is what this is all about. Check out our mastermind down below.
We're gonna try and change. We're gonna try and change one of those minds today. Actually, that's gonna be the purpose of the Q&A today. So with that, I'm gonna go ahead and share my screen. All right. So today, what we're doing. Let me go here. I'm gonna touch on this today.
Oh, and Cheryl McRae is going to be on the spotlight next week.
Yeah. So this week we were supposed to have. Is it McRae or McCrary?
McCrary.
McCrary.
Yeah, so we were supposed to have Cheryl McCrary on the community spotlight today, but she had to reschedule for next week. So this week we won't be doing a spotlight. We didn't have enough time to add another person, so we decided we'll skip the spotlight and we're going to change the Q&A today. And I know it's annoying looking at a virtual avatar of me, but I'll be back live next week. We just want to test this and see how well it comes through. We want to watch it back and see how it looks. So this week, what we're going to do something a little different in the Q&A. So we're going to answer questions the same way, but our goal today will be to change the mind of a current Industry 3.0 professional. There's one person who, well, it's not just one, but there's one person we picked out who's commented on several videos. He's written some very long comments, challenged, they're very common points. We hear them all the time when we're presenting organizations. So what I want to do is I want to answer all his questions. So we decided to do that. We'll have the time because we're not doing the community spotlight. So I think we're going to answer 5 questions from him. Some of them are long, but I assure you, if you sit through me reading them and then I give my answers, it'll provide value. You might be able to use the answers I give you to overcome objections within your own organization, i.e. Henning, who has a question this week I'm going to respond to. So a couple of updates. This week we have our monthly 90-minute mentorship meeting this Friday at 8 o'clock, 8 o'clock in the morning Central Time. And I will be presenting that. I actually just finished my presentation. So if those of you who are in mentorship, remember we have our monthly meeting this Friday at 8 a.m. Central. Module 2, now that the latest release of Factory Studio came out, we're working on Module 2 for Frameworks University. It's in progress. Hope to have it done in another 7 to 10 days, give or take, ready for everybody to use. And I'll talk more about that in the mentorship meeting. Number 3, good news, HighByte Intelligence Hub. Version 1.4 got released. So I want to go through the release notes. There are a couple of major items that have been added into the platform that I want you guys to see. So there are 8 release notes if you haven't read these already. So they've added in some additional features into version 1.4. Number 1, you can use multiple flow inputs and outputs. So let's say you've created a boiler model the 10 boilers you have at your facility. Now you can write a single flow that sends data for all 10 of the boilers to an AWS IoT core topic, or all the boiler data to multiple outputs like a REST endpoint for debugging and Azure IoT Hub for production. Basically, you're allowing a many-to-one relationship between the input of the flow or the output of the flow. And it used to be a one-to-one. So there would only be like one input and one output to the flow. Now you have many. It's supporting many inputs and outputs. Remember, the way that it works is you have connectors in HighByte Intelligence Hub, then you create models, and then you have flows that take your connections or your models and map them to outputs. That's how the work process flow in Intelligence Hub. Number two, you can see your data. This is one of the ones I'm very happy about. You can easily create and test any input in the UI. So allowing you to see what data and schema the input returns. You're not sure where the amps attribute was in that JSON payload. Simply expand the input in the expression builder and see all the data and schema right in the UI. Before, the way that you had to test to see what the data values were from a connector, you needed to map it to an output and then go to the output and see what the value was. Now, within the Intelligence Hub engineering interface, you can look at the actual values of the data. So that's
like a preview mode.
Addition. Yeah, it's well, think about it this way: like like a big difference between Factory Studio and Ignition is in Ignition, you can go into the designer and you can see the value of your tags, right, as they change. In Factory Studio, you can't do that. You have to go to a separate monitoring mode to do that. Now they'll be adding the values in, but in HighByte Intelligence Hub supports monitoring the values from within the engineering interface. Number three, you can now work with arrays. So arrays are everywhere, from OPC UA arrays representing set points in the PLC to an array of JSON objects representing a motor running hours from a maintenance system. Now the Intelligence Hub supports inputting and outputting simple and complex array types. You can index arrays and expressions, slice them, dice them, and even build arrays out of primitive OPC UA tags. Okay. Another big one, read CSV files. So now you can read and parse a CSV file using HighByte Intelligence Hub. Many older industrial devices, especially testing equipment, write their data to CSV. You can now use a CSV input to read the CSV, and that file can either be static or the input can index files, reading them in chunks and moving them to a completion directory when done. Number five, you can get more from OPC. The big thing is now we can encrypt and use username and password to authenticate. And you can also output a model to a tag group in an OPC server. Okay. Number six, you can have SQL data. You can move SQL data into and out of your unified namespace. This is a big lift. Very happy that this is in here. So you can now read multiple rows from a SQL table, and then you can run them through a model to do things like change a column name or add in new data. So what this is allowing you to do is read data from one SQL table and then add additional context, transform that table into a completely different data set. Well, I could add a column for another data point that I want to merge with it, right? And you can do that without having to fundamentally change the originating table.
Yeah, and that's one of the most requested features, by the way, is getting,
correct.
How do I get SQL data in and out of my unified namespace? If anyone asks that, I'm going to link them right here.
Correct. In fact,
well, we can go into it once we dive deeper into the software too, but.
Correct. And Aaron, and we're going to demo this. Aaron Semley reached out to us before they finished this capability to get clarification from myself and a couple of other members of our team on what we tell our clients when they ask us about querying data through the unified namespace. And we, gave them some guidance in terms of, what it is we would be looking for in a feature like this. So you can now then take that data, transform it from a table, and then output it to an MQTT broker as an array of JSON objects representing each row. This makes getting SQL data into your unified namespace easy. The SQL connector output also now supports table creation. So now you can connect an MQTT input into the unified namespace, subscribe to a topic, and output that data model directly to a SQL table to review the data locally. That's a big step. SQL outputs can also call stored procedures or log data as JSON in cases where the model schema isn't finalized. You can now leverage REST templates. So for those of you who are like web developers or are really big into development with software APIs, you now can leverage templates within a REST interface. What VR software is Walker using? I am Mike Taylor. I am using, this is Immersed VR. We use Teams. So we use Immersed for immersive work. So I have my desktop in front of me here in the virtual environment, and it's just a big, massive, huge screen. And then off to my left here, I have an extended desktop that I'm able to look at where I'm watching your comments. I'm using Immersed VR with an Oculus Quest 2. All right, leveraging REST templates. Do you need to get data into InfluxDB using their line protocol or Elasticsearch? The REST output now allows you to transform the default JSON output to any format you need, including XML. This makes integration with REST-based interfaces easy and flexible. And then the last one, which is a big deal, you can enable cloud to edge with MQTT. All right, I'm going to show, it's kind of ironic. One of the things I'm going to be showing you is we're going to review digital threading again today. And one of the capability gaps, one of the data gaps, there are data gaps and capability gaps in using digital thread architecture for digital transformation. This new capability with HighByte Intelligence Hubs closes that data and capability gap. And we actually have a couple of really large enterprise customers where this is going to make a huge, is going to have a huge impact, one in the pharma industry and one in automotive, where we have spec'd HighByte Intelligence Hub into their IIoT infrastructure for this very reason, knowing that this feature was coming. So we can enable cloud to edge with MQTT. What does that mean? You can now support, so the MQTT connector in HighByte now supports inputs and secure TLS connections. So that means you can consume from the broker, which before you couldn't, it wasn't baked in yet. But now you can connect to an MQTT broker like the AWS IoT Core, and then you can enable cloud to edge use cases where, and here, one of the biggest things that's missing, I'm going to go over here in a second, is there is context that gets created in the cloud, in your cloud infrastructure, that never makes its way to the plant floor when you use the digital thread architecture. That is, the data itself is meant to be accessed only through the analysis and visualization layer in your cloud IIoT solution. It's never meant to take the data that's created in the cloud and get it back on the plant floor in raw form to be used by applications on the plant floor. This jumps that hurdle. Okay, so for example, cloud edge use cases where machine learning alerts generated in AWS can be sent down to HighByte Intelligence Hub, transformed via HighByte modeling, and then output to protocols like SparkPlug-B or OPC-UA, making the data immediately available in any Sparkplug-enabled SCADA system like Ignition, or you can do the same thing with OPC-UA, send it to any SCADA system that supports OPC-UA. Another common use case with a similar data flow is streaming sensor data to the AWS IoT Core from a third-party sensor provider like LoRa style sensors. This data can then be pulled in, modeled, and output to the SCADA system using the HighByte Intelligence Hub. Okay. The point here, release version 1.4 of HighByte Intelligence Hub is a big fucking deal, and you should go check it out. Okay.
Hey, I want to say, HighByte, it appears though like the releases are getting quicker, and each release is getting more and more features. Like the rate of innovation is growing rapidly at HighByte. That's
Correct.
really cool to see.
And what I want to do is I want to take an opportunity here to I want to talk about digital thread again. Okay, and here's why. If you guys are, if you were to go meet with a client and you were to ask them, hey, what are you doing with IIoT right now? They're really going to give you one of three answers. Okay, answer number one is we're not doing anything with IIoT. Like we're not, we want to, but we haven't. We don't know where to start. Okay, and that's where mentorship and digital mastermind is all about training people how to answer those questions for your clients. We don't know where to start. Okay. Answer number two might be, oh, we're partnering with Rockwell using their Factory Talk stack. So that Factory Talk stack is almost certainly going to be something like Rockwell PLCs on the edge, OSI Pi, using OSI Pi connectors up into the PTC ThingWorx, the Factory Talk Innovation Suite stack. So it's a digital thread, basically but it's solution-centered digital thread. The other option is we've adopted Azure IoT and we're using IoT Edge and Azure IoT Core in a digital thread architecture, or we're using AWS in a similar architecture. The third option is we have created our own edge device. We've created our own infrastructure. In basically 99.9999% of the cases, if you are type 2 or type 3, type 2, I'm using a solution-centered digital thread, or type 3, I'm doing my own thing, you're doing digital threading, okay? And I want to explain what a digital thread is and where the gaps are, okay? So this is what they generate. So if these are all the layers in our business where data and information is generated, okay, and understand that the ERP layer and the MES layer is sort of a catch-all. I mean, basically any business application, no matter what it is, if it's on the carpeted side of the business, falls under ERP, and basically any business application, no matter what it is, that falls on the plant floor that's on the plant floor, on the hard part of the floor, is going to be in the MES layer. So like rescue management, all that kind of stuff. Those two are catch-alls, right? But this is the stack where all of your data gets created in an industrial environment, right? So you have standard capabilities in data. So on the left-hand side here is some examples of the various nodes where data and information can get created, okay? On the right-hand side is the general approach, which we refer to as the digital thread. So if you want to see an example, we did a video, AWS versus Azure, and I explain what digital threading is. But here's how it works under the hood, okay? How a digital thread works. So I'm going to put an edge IoT gateway out on the plant floor. And in this case, we're just going to say we're going to talk to a PLC. So the PLC is talking to the sensors directly. And then in my edge IoT gateway, whether that, doesn't matter what it is, whether that's a AWS IoT Edge or Azure, it's going to have a couple of things. It's going to have a native connector to talk to the PLC. It's going to have an abstraction layer, so it can take the unlike data from this sensor. So the neither of those sensors are standardized. We have to get them into a standard model. So there's going to be an abstraction, which maybe puts it into a sensor model. That edge IoT gateway is going to have a local data store that may just store the raw events that it picks up, maybe for only an hour at a time. Maybe I only store the last hour worth of data. There'll be a local store, and then there's going to be a native connector that takes that model and converts it into some protocol. And and if I did a homebrew, I may have selected OPC UA or AMQP, or I may have wrote my own custom TCP/IP protocol. Okay, that data those events are streamed directly to the cloud, and they run through a connector that speaks the same language that this connector does, and then directly into a data lake. Okay, so we just basically try to get everything from the edge into a data lake as quickly as possible. And then when I want to do something with that data, say I want to build dashboards, or I want to do some analysis, or I want to look at trending, whatever, I'm going to retrieve the data from the data lake, which the digital thread gets created here. That digital thread is based on this model that's generated, the model for the sensor, or the model for the tank, or the model for the pump. Now my analysis layer is going to retrieve the data from the data lake, either on a case-by-case basis. So I'm going to have a data scientist or an integrator do a one-off integration to retrieve, say, a custom model, or I'm going to use a suite of solutions that speaks or that's able to retrieve this model right here. Okay, so the analysis layer queries for the model, and then the visualization visualizes it. Okay, that's the digital thread. Here's the problem with it. The problem is that it assumes it makes two faulty assumptions. Number one, that all of the value, all of the innovation that I can get from using this data can be acquired or achieved through these visualization layers or some other tool that can talk that is part of this stack. Number two, it forgets that there's context, there's data, there's events that get created up here that we never get back down here. We assume that if we want to access them, we're going to get them up here. There are events that are created that they bypass completely. Context and events in the HMI layer, the SCADA layer, the MES layer, the ERP layer that they completely forget about. And so the data lake is missing, has data gaps, and the visualization has capability gaps because there's data missing. That's the problem with the digital thread. Okay, it doesn't mean that the digital thread doesn't provide value to an organization. I can't unlock, new efficiencies, right? But what it does mean is that the solutions you can develop are not all inclusive with this architecture. There's a lot missing. And the way that we highlight that is this. You don't have normalization, you don't have abstraction, there's no standard with the exception of the standard for the models you're using. There are lots of data gaps, primarily at the other layers of the stack that this digital thread doesn't account for. There are capability gaps. Those are features you can't build because you're missing data. You can only have to go after high value targets because that's expensive. You create completely new data silos. That is, there are events and data that's up here in the cloud that no one else can get to. And it doesn't unlock innovation on the plant floor. What it means is there's no mechanism to get this data back to the plant floor. Okay, so that's the flaw with the digital thread. The advantage, one of the ways that we close this flaw, okay, one of the ways we close this gap is we put in an IIoT platform here that allows us to talk to this infrastructure. And here is where, and it's through this platform that we basically create a virtual edge device that then can stream into this infrastructure. And this you guys know as the UNS. Okay? Zach, did that come through clear?
Yes.
Yeah, it did. Make the UNS a little bit bigger though.
Okay. Any questions about that, gang? Before I get to the questions.
So one of the things is
this is a really important point here.
Everyone thinks about going edge to cloud, but no one thinks about going cloud to edge.
No one thinks about going cloud to edge, and everyone forgets that there's context that's created, context and events that are created at other layers in the stack that they cannot account for. The Edge IoT Gateway assumes that the most important data are the raw transitional events from your sensors. And as a function, it ignores other really important contextual data. And we're going to get to that here in a second.
Are you going to bypass the UNS and go straight to the data lake for certain digital threads, or is everything going to go through the UNS?
Everything should go through the UNS. Excuse me. But there are use cases where you're streaming directly into the cloud. And an example, a really good example would be on super high frequency data. Like, we generally don't, through the unified namespace, we are generally not updating topics in an MQTT broker at a rate faster than 250 milliseconds. In some scenarios, maybe a half a second, 500 milliseconds. But there's high speed telemetry data where I might be doing I may have 90,000 transitions a second total in aggregate. That I don't want to run those 90,000 through the broker. What I want to do is stream that, stream that directly into the cloud through, a streaming optimization tool like Apache Kafka or something. So there are scenarios, or there are use cases where it's point-to-point edge sensor collection directly into the cloud. But those are primarily only for high frequency, super high frequency data. Okay. All right. I'm gonna go ahead, Zach.
Yeah, there were no more questions, but there are a lot of people joining live still, so it seems like it's holding their attention. Oh, Blake Moritz said, "What is the best gateway to connect my sewing machine to Azure?"
The best gateway, and I think he's using sewing machine as a metaphor, but it's going to be Azure IoT. It's going to be an Azure IoT gateway running on probably an HP because they have containers for the HP devices. But if he means a literal sewing machine, you better put instrumentation on that sewing machine first.
Is he making a pun about the digital thread?
Yes, he's making a pun about a digital thread. All right, so what we're going to do today, guys,
Rafey actually is a textile guy, though. So if you need help with textiles, reach out to Rafey.
So let me. So what I'm going to do is there are 5 questions from this guy, Mark McMillen, that I'm going to answer. Okay. They are all questions where he's challenging stuff that we've said in videos, and these are all points that have been brought up many times in our presentations with clients and with other people who reach out to us directly. And so what I'm going to do is give you guys an opportunity to see how I answer these questions. So these are going to be what we refer to as objections to the Industry 4.0 methodology. Okay. So what I'm going to start with is this. Mark McMillen, I don't know if he watches the live stream, but if he does, I would encourage Mark to take the IIoT mini course, our free IIoT mini course, to get some foundational understanding of the concepts that we preach, because that might help clarify for him. But what I'm going to do is give everyone an opportunity to see how it is I overcome these objections, and I'm going to give you the exact answers I would give if I'm in a conference room with a bunch of process engineers. Little background on Mark. He's a process controls engineer. He primarily worked in paper. He started out in paper and then he did a bunch of integrations. He's a big DCS guy. He's a big process guy. Okay. He's been a process controls engineer and it looks like a programmer, for the last 20 years, give or take. His objections here, I've heard, this is probably going to be, in the last year alone, I've probably answered these questions that he's raised hundreds of times. And so you guys are going to get a chance to see how I answer them. So Mark McMillen in the OPC, the future of IIoT, OPC UA, he commented here, this idea that new equipment just shows up on your network is extremely problematic from a security standpoint. One must assume that any new device in a plant must adhere to the security and privacy protocols of the organization first and foremost. Totally agree with Mark, but what I would say to Mark is, hey, Mark, your security and privacy protocols were designed for a type of technology that is moot, and that is server client. So server client poll response. Okay, that is server side configuration, server client relationship, poll response, data retrieval. Okay, part of the reason that the equipment can show up on the network, just show up on the network, is because the connectivity and the data transfer is instantiated by the edge piece of equipment. Okay, so what that means is that if assuming that the people who are installing the equipment on the plant floor have permission to do so, you give them the keys to plug into the network, and you give them the configuration you want them to set up on that machine, so that machine can just show up on the network. Okay, So yes, he's correct. We must assume that any new device has to adhere to the security and privacy protocols of the organization first and foremost. But what you have to understand is that a piece of machinery that adopts the methodologies, that is an edge-driven, report by exception, lightweight, open protocols, doesn't have the same security risks as one that uses legacy technology, that is server-client poll response, okay? Also, just what is all this data that's so important for the enterprise? I've been working in automation for over 20 years, and the most important information is still the basic process parameters like flow, temperature, pressure, all of which is already collected via ancient 4 to 20 milliamp signals. Do you really need device serial numbers, manufacturing date, and other such information? In some situations, I've seen engineers request data that rarely changes, like the derivative component of a PID controller and a PLC. Notice he didn't say never changes. He said rarely changes.
Hey, I'll bet AI changes it. I'll bet AI changes it.
That's correct. And so
or makes a recommendation to change it. Makes a recommendation.
Correct. My total response here will address. And yet I've also seen IT departments balk at the process data resolution needed for proper process analysis because it requires too much historian space to store. All of this leads me to conclude that the vast majority of this IIoT stuff is vast overkill and nearly completely unnecessary. Much of this has been available for decades via HART, which remains vastly underutilized. Let me start with this. So Mark's experience is, and I respect everything that he said here. And if he were in a conference room with me and he raises this objection and he's almost going to do it condescendingly while he's rolling his eyes and he's calling what we are pitching the flavor of the month. That's what he would be doing, right? It is a function of the fact that his experience is as a process engineer on the plant floor. And so he's only talking about the data that's important to him. In 20 years as a process engineer on the plant floor, there are many layers of the business he is totally not privy to. He's a process control guy, and therefore he's only talking about the data that matters to him. And I respect that. But what he has to acknowledge is that Mark McMillen isn't the keeper. This process engineer isn't the keeper of all data for the entire business. Okay. Number two, just because a data point changes once a week, once a month, once every 6 months, once a year, doesn't mean that that data point isn't important. For example, if you calculate profitability, profit margin on a quarterly basis, that doesn't mean that you should, just by virtue of the fact that it changes once a quarter, you should manually move that data after calculation. There's no reason not to collect that natively. That is, when the data point updates, the time that the data point updates matters. That actual event matters, okay? It may not matter to the process controls engineer, but it matters, okay? And so while he doesn't care about the serial number, and he doesn't care about when that instrument was manufactured, or he may not personally care when that sensor was installed on that machine. But the CMMS does. The maintenance management system or the enterprise asset management software cares about that information. And simply because a process controls engineer doesn't care about it doesn't mean that it should be excluded from data collection. There are and that's an important point. I want to go to HART here real quick. Much of this has been available for decades via HART, which means vastly underutilized. Here's the problem. And for those of you that don't know what HART is basically a 4 to 20 signal that has context on top of it. What it is HART is an open protocol that you use on the edge. It's used on the floor. It's basically a sensor protocol that allows you to send contextual information over a 4 to 20 field connection, a 4 to 20 milliamp field connection, okay? The reason it's underutilized is because guys like process engineers don't care about that contextual information. And the people who do care about it don't use software that supports HART. That's the reason it's underutilized, okay? So anyway, that would be the way I answer that question. He raises that objection. I would stand there respectfully while he's yelling at me and rolling his eyes and all that, and then I would give that answer. The point is that the paradigm has changed. Okay, when he talked about they couldn't get the kind of data that they wanted. Remember, digital transformation fails for one of three reasons. You have the wrong strategy, you pick the wrong technology, or you have the wrong partners. In this case, when he says, I've seen situations where engineers request data that rarely changes, or I've also seen IT departments balk at the process data resolution needed for proper process analysis because it requires too much historian space to store, that's because you've picked the wrong technology. Okay, that's the reason your IT department isn't using minimum technical requirements to pick their solutions. They're going to OSI Pi, and OSI Pi doesn't care how many disks you got to buy. Okay. All right. Question number 2 that he asked is a comment under 7 things systems integrators are doing wrong. Mark said, and he agrees with me here. So I think most of those were valid observations in the video where I said 7 things SIs are doing wrong, but you have to account for what customers are actually hiring SIs to do. The SI business is geared to address the most common types of projects, which aren't those things you described. And most manufacturing organizations have built-in departments that believe they're the best at doing most of those other things, whether they are or not. My opinion is that most companies would be better off if they locked off their entire IT or DT group and outsourced it, because most IT people spend their entire workday justifying their own existence. He and I are in agreement here. What I will say is that when I was talking about the 7 things systems integrators are doing wrong, I am not talking about the integrator who specializes in a single industry or a single type of projects. Yes, Jeffrey Schrader, that's a good example. Heart is context for an instrument, but it's not context for an enterprise. And the point that I would point out there, Jeffrey, is that Mark is speaking from the perspective of a process controls engineer. And when I'm in a presentation and I'm talking to an organization about the need to digitally transform, I'm not speaking just to the process controls engineer. What we're trying to do is unify all the data and information across the entire organization. Right now, gentlemen like Mark, process controls engineers like Mark, are focused on just one small area of the organization. Just one small area, one small collection of data that he thinks is important. But he has to recognize there are people within his organization who view other pieces of data as incredibly important. Raghu Create said, IT-OT convergence is a complex topic. Based on your experience, what do you suggest companies, conservative-minded, that need the ROI, that are in their infancy period of their digital transformation, start with? They need to start with inventorying the business and inventorying the intelligence. So to answer your question, Raghu, every organization, I can tell you this right now, the mandate that I tell my team is this: we do not start a digital transformation project until the organization, the customer we're talking to, has a strategy and an architecture. If they've already have a digital strategy and they already have an architecture, then we start by evaluating those 2 things. What is your digital strategy? What is your architecture? If they don't have that, then we start doing a digital transformation maturity assessment so that we can inventory the business, inventory the intelligence, and then help them define their strategy and their architecture. If you, and I make this very clear to Intellic Integration, my engineering company, if the client does not have a strategy and they don't have an architecture and they tell us they just want us to do a proof of concept, we're not doing it. Period. If you try to start your first digital transformation iteration, your first project, with no strategy and no architecture, you're wasting your fucking money. You're wasting it. You're burning it. You might as well go have a barbecue with that money. And I'm telling you, I've been doing this a long time now, and the first digital transformation initiative fails in 90% of the implementations because you've picked the wrong strategy, you've got the wrong technology, you're using the wrong partners. Okay. All right. Next comment. All right. I'm only going to read the first. I know this is long, but trust me, the answer here is is worth it. Okay. We really went back and forth. You guys really want to hear me read two paragraphs, but I want you guys to see how I overcome this. So in the video, the future of historians, Industry 4.0. Now, I highlighted for Industry 4.0, what is the future of historians? Now, I did not say that for an Industry 3.0 company, historians have no value. And I didn't say that historians have no value. What I did say is, what is the future of historians for an Industry 4.0 company? Okay. So Mark says, okay, I've got several problems with this. Some plant data is discrete, like how many bins of acid are in the process area. But most process plants also generate a vast amount of time series data. Think flow rate of caustic in gallons per minute. You need a historian to collect, timestamp, and store that data, and sometimes it needs to be fast, like 1 sample per second. Number one, I do not accept the premise that you need a historian. What I would say is you need something to collect, timestamp, and store that data. That doesn't necessarily have to be a historian. It could be an edge array that publishes into a unified namespace that ultimately gets that full high-speed data into a data lake. But his point is accepted here. When he says historian, I think what he's talking about is OSI Pi, Canary Labs, Wonderware historian, GE solutions, et cetera, et cetera. What I'm saying is you don't need a historian, but you do need to collect, timestamp, and store that data. And by the way, that timestamp better not be coming from the historian. That timestamp better be coming from where the event originated. Okay, but his point is understood. A data lake is nothing but a big database, and none of them are designed to collect time series data in an efficient manner. This is simply not true. What in his experience, the architect who is streaming that data into the data lake is in all likelihood not using time series optimization prior to pumping the data into a data lake. An example here would be using Apache Kafka to optimize and stream the data into a data lake. Okay. I worked for a Fortune 500 company that operates a data lake. The plant historian was set up to collect process data for various types of analysis. The ID department insisted that we funnel that data to their data lake, and all access to the data would be through their applications. I would refer you back to my digital thread comments early in this conversation, because that is exactly what that you're going to see. After a couple of weeks, engineers realized that the resolution of time series data in the data lake was maybe 30 seconds at best, some far worse. Here, what I would do is reference you back to, if you're going to fail, you're going to fail because you got the wrong strategy, you're using the wrong technology, you got the wrong partners. We have examples of straight edge to data lake data streaming for 90,000 transitions per second. So that's 90 kilohertz for a single data point, or at aggregate 90 kilohertz, 90,000 data points in 1 second. Going edge to cloud. I see Michael Brown is on here. I guarantee Michael Brown from AWS. I guarantee Michael Brown is going to be able to give you very similar examples of being able to take incredibly high speed, high resolution data from the edge and streaming it directly into a data lake for retrieval. We've done it many, many times. Okay. So what I would say here is that with Mark McMillen, his experience is a function, or his knowledge is a function of his experience. And in this use case, he may have observed exactly what he's saying here. He's saying 10 gigabyte plus per second of data from edge directly into the cloud. Michael Brown is. So that is 10 billion, right? 10 billion plus per second.
10 gigabytes per second. 10 gigabits per second.
Right. That's big. That's in the that's in the billions, right? So lots of different analysis was required, data resolution down to the second, but IT was adamant that they can never store data at that resolution. After much gnashing of teeth, we negotiated them down to 10 seconds and some data only. You see, data lakes are just server farms, and each server costs money. Totally agree with you. What I would say is those servers are getting a lot more cheaper today. So they aren't sized to hold that much data. That simply isn't true when it comes to cloud infrastructure. And IT managers start having seizures when you send them 50,000 tags at 1 second resolution. We've built systems that have 11 million tags at half-second resolutions. And the total monthly cost for 11 million tags was less than $10,000. Okay. You need a historian for that. You don't need a historian. You need something to store all those events. Okay. So what happened at the plant? We redirected engineers to pull data for analysis directly from the historian, as it should be, and IT kept collecting their meaningless data at 1-minute resolutions. Also, the crappy interface IT provided to view and pull data from their data lake was a hilarious joke. It was a great advertisement for systems like OSI, Prophecy, and IP21. You could be right about historians disappearing, but no way that happens in 10 years, 50 maybe. The only Industry 3.0 companies that'll still be operating 10 years from today, you can take this to the bank. The only Industry 3.0 companies that'll be operating today, 10 years from today, are going to be the companies who have their market cornered or they have some niche. If a competitor can arise and leverage technology to steal their market, it's going to happen. So if you're a company who, for example, you own a recipe and the recipe is the key to your market, that is, there's a recipe, I may make sugar water that's got a specific recipe for it. You don't have to worry that someone's going to steal your recipe because you own it, right? You still own the market. Or if you've got a super powerful brand, your brand is super powerful, and as long as the finished good advances with the times, then the way you manufacture it doesn't have to. You probably are okay. You're in a niche. But the vast majority of manufacturers are going to see competitors pop up out of nowhere, and those competitors are going to eat them alive because they've built up. I mean, imagine that imagine that you were transporting all of your goods by horse and buggy, by horse and wagon, and you believed that you didn't need to purchase a gas-operated vehicle or use a steam locomotive or a boat to transport your goods from one place to another. That's what Mark is advocating for here. Okay, I'm going to move on to the next one. My point here is that Mark's lack of understanding here is a function of he is not privy to technology that is available in the market, readily available in the market today, and his only experience with digital transformation or cloud technology was based on a flawed strategy using flawed technology, which I say all the time. This is a good one here. I want to just point out, I'm only going to read the first paragraph here. Mark says that I keep hearing you say things about a DCS that are simply incorrect. Let's get the basics down. A DCS is a distributed control system that isn't really distributed much. A DCS is not process specific. By the way, I didn't say that a DCS is process specific. I said that a DCS can be process specific. You will see scenarios, and I use the ABB example, where ABB developed a rolling mill application in the ABB DCS that they sold to many steel operators who operate rolling mills. I did not say that a DCS is process specific as an absolute statement. That's not what I said. In fact, before I made this answer, I went back and watched the video again with Zach saying, man, did I say that it was process specific? And I watched it and no, I did not. He said any DCS can be used for a wide range of processes. Absolutely true. In fact, I said that DCSs can come completely blank. There are certain systems that were developed for a specific process or industry, such as the GE Mark VI for turbine control. Mark has experience with GE in aerospace, so I think that's why he's referencing the turbine control in the Mark VI. But even those can be used for other processes as well. I suppose there are some very niche processes that have a very specialized controller platform that is used for that purpose only. Burner management comes to mind. No, a really good example would be oil and gas refineries. Another good example would be energy and management in wind, solar, and natural gas generation. I mean, there are scores of examples of DCS implementations that are specialized. But you are grossly misleading people when you say things like a DCS is process specific. It's just not true. If I were saying that, by the way, if I were saying that, I would be misleading people. But I did not say that. I did not say that DCS is process specific. What I said is that let's say that I'm going to build, I'm building a rolling mill. I'm not going to buy a ControlLogix PLC and then use a bunch of ControlLogix remote IO and start from complete scratch writing my program. That is not what I'm going to do. What I'm going to do is buy a distributed control system that already comes with function blocks that are specific to roughing stands, that are specific to 4160 VFDs, that are very specific to finishing stands at the end of my rolling mill. Or I'm going to do the exact same thing for the energy sector. That's what I was saying. But the point that I really stressed here was that DCS, and by the way, he talks a little later that in the field, that the remote devices speak Ethernet IP. The Rio devices speak Ethernet IP back to the controller. One of the biggest advantage of DCS is the fact that the remote IO speaks to one another over field bus, and that is a prerequisite for super high speed process control. Okay. Anyway, I wanted to. This was kind of a separate point. Mark McMillen said, I haven't. By the way, I haven't read this question here, so let's read it now. Most of the embedded data in devices that you reference has been available for decades via HART and other carrier wave protocols, but plant personnel have never seen the value in having that information. Again, someone on the plant floor may not care about that contextual information. A process engineer who's been a process engineer for 20 years may not care about that. But if he had moved up the ladder in his organization, okay, if he had moved up the ladder into his organization, and let's say he became the executive vice president of process engineering for his organization, he would care, okay? Mark probably has never worked in and I'm not picking on Mark here. I mean, these are very common objections he's raising here. But Mark is making declarative, and by the way, I've been in presentations where the process engineer literally is speaking to me as if he's the only person who works at that plant, or he's the only person in the organization, and therefore the data he thinks is important is the only data that's important, or the data that the people who work in his department that they think is important is the only data that's important. The reality is that in a digitally transformed organization creates an ecosystem. And they create that ecosystem understanding that all data is important. If you don't think that collecting data about individual nodes is not important, then I would ask you this. Why are Facebook and Google two of the most powerful companies in the world? Because they are data collection companies. That's all they do.
They care about our serial numbers. They care about our date that we were installed.
They collect information about us. In order for you to leverage machine learning and artificial intelligence to create value, the first thing you have to do is have the data for machine learning and artificial intelligence to analyze.
Mitt had a question about the PLC.
Who did?
Mitt or MIT.
Mitt SVHA said, why are you against POCs as companies want to get comfortable to try out with new technologies? They want to start with small funding and demonstrate value to internal stakeholders and then scale. I'm not against the proof of concept. I'm against starting with the proof of concept without an architecture or a strategy. That's what I'm against. But yeah, I agree. No, POCs are the next step. After you inventory the business, after you inventory the intelligence, you come up with a strategy and an architecture. The very first thing you do is do a proof of concept. What I'm saying is you don't do a proof of concept unless you have a digital strategy and you've designed an architecture. Because the POC, the proof of concept, is going to prove that your strategy is going to work and your architecture is sound. That's the hypothesis you'll be testing.
Yeah.
The proof of concept is testing a hypothesis that you are establishing with your strategy and your architecture. But yes, and somebody else, Seahawks, said, maybe I'm not understanding. Saying technology POCs aren't important doesn't make sense. Right. I'm not saying the POC isn't important. I'm saying you got to have the strategy and the architecture first. Sorry, I apologize if I confused anyone with that statement. I do apologize. Yeah.
So you're saying, Walker, like through a proof of utilizing a proof of concept, you're not going to find out what your architecture or your strategy should be. It's the opposite way around.
Correct. You're going to start with a strategy and an architecture, and through the iterative process, through the agile process, that you may modify your architecture. There may be something you test during the POC about your architecture that you discover, hey, this isn't going to scale, right? But you're not going to do a POC without initially having a strategy and an architecture. And what I tell my team is, let's say a client brings a digital, they don't have a digital strategy. They come with a basic architecture that they got from some OEM, you know, likely Rockwell, or maybe McKinsey gave it to them, whatever. And they say, we want to do the POC and we want to use this architecture. If our organization, if our team, based on our experience, knows that that architecture is flawed, it's not going to scale, we're not doing that POC. We're going to tell them, go have a barbecue. You know, what you need to do is let's start at the beginning. Let's inventory the business, let's inventory your intelligence, and let's modify this architecture. Yes, I know you spent a couple $1 million having McKinsey come through and give you the same report they give to every single one of their customers. Or maybe you paid Rockwell to do the same thing. By the way, I keep reading these Rockwell reports. They write like these 95, 100-page, you know, digital transformation reports, and like 90 pages are exactly identical. Even more than that, maybe 93 pages are exactly the same for every customer. No change whatsoever. I mean, it's nothing more than a document for them to sell their solutions. Let me go ahead and finish Mark though here. This will be the last question. Most of the embedded data and devices that you reference has been available for decades via HART and other carry-away protocols, but plant personnel have never seen the value in having that information. I've personally struggled to convince management that this data might be of use for years. I think it's because for the vast majority of sensors and control elements, most of this data has little value beyond the concepts of predictive preventative maintenance. Sure, Tesla is probably highly invested in this sort of data, but is a glue manufacturer, a paper mill, or a steel plant really interested in it? Yes. I mean, I was an engineer for Newport Steel for 5 years, and I promise you that the implementations that I do now, that I've been doing for the last 12 or 13 years, I first tested them in a rolling mill in upstate New York for Newport Steel. Not that I've seen. Go into any heavy industry plant, you can easily find scores of devices that are woefully out of date, many that don't work at all, and lots that are configured incorrectly, and yet the plant still runs just fine. It runs just fine because you're not competing against someone who's leveraging technology to do more with less. Your standard of just fine is flawed. Just like when Kodak says, hey, today we're doing just fine making cameras that process film. We don't need to keep this digital photo technology because today we are running just fine. Convince management to fix or replace all those devices that barely work first, and then let's talk about connectivity. What I'm saying is that I get that response all the time, and what I would try to do is, as respectfully as I possibly can, I would say to Mark, that's the reason you're a process engineer and you are not a chief technical officer, and it's also why you are not an EVP who's responsible for strategy. And I would say it as respectfully as I possibly can. Okay. The reality is just because what is just fine? Because I assure you that the leaders of your organization do not believe that you are running just fine. I guarantee that they want you to do more with less, that they want you to become more efficient, and that based on their market analysis, they feel competitors breathing down their neck. Matthew Kendall, what isn't measured can't be managed. Heart data, primarily config settings, versus how long a machine took to perform a step is very different variables. The ignorance is glaring. Well done, Matthew Kendall. Yes. Again, what I would say is that based on, and Mark used to work for, this is a very accomplished process engineer. This is not, this guy right here is no, I don't waste my time on people who I don't think have technical skill. So obviously this guy has technical skill. He's obviously going to be respected in his facility. And if what you want to do is convince manufacturers that they need to digitally transform to keep their people employed, then you've got to convince people like Mark, because
right.
He's going to be sitting. By the way, in the meeting, he's probably not going to say anything. He's probably going to go back to his department and say exactly what he's saying right here.
And he's going to destroy the POC.
That's right. He's going to destroy the POC. Not that he wants to destroy the POC. It's just that he believes. I mean, this Mark is not unique. This is not a guy I would describe as a caveman. This, what I would say is, that's right, Jeffrey Schrader, he will quietly conspire. Why? Because he believes it doesn't provide value. And his belief that it doesn't provide value is a function of his experience and his knowledge. This is why we talk about one of the biggest challenges that Industry 3.0 companies have to overcome is their experience and success. That's a challenge. When you are a current day auto manufacturer, if you had asked anyone 5 years ago, do you believe that that Tesla is going to overtake the automotive market? They would have told you were crazy. If you had gone to Ford or General Motors or Chrysler and asked them, hey, is Tesla going to put you guys out of business? They would have laughed at you. They would have laughed at you. They would have said, we're doing just fine. Especially General Motors. We're running just fine. They're not going to be running 5 years from now. Digital transformation is a strategy. And it is a strategy that takes time. Michael Brown's on here. Michael Brown spends all of his time helping manufacturers architect the digital transformation strategy, leveraging AWS tools, right? And tools that play nice with AWS tools. You don't do that in a month. You don't do that in a year. You don't do that in 2 years. You get started in 2 years. It takes 2 years. Most of our engagements are from when we first start with a client to when we're stepping back into a just purely consulting role and advising their team as their team keeps going through the iterative process to transform the organization. That is generally a 2-year engagement. It is generally 2 years of us going through analysis, and then doing proof of concept, and then doing pilot, and then going to scale, and then iterating. As the company's collective knowledge expands, what they want changes, and you got to have a mechanism to adjust to that. Mark is firmly entrenched in an Industry 3.0 mindset. And I hope that by me going through, what I'll do is, by me going through and responding to these questions, his questions, I'm giving you guys insight as to how I respond to these objections when we're within the organization. Yeah, and by the way, next week what we'll do is I want to start with this one right here. I'll answer this last one here. Does anybody have any parting questions?
Stop sharing for a second
before I drop.
So we can close it out.
Yeah.
I didn't see any more questions, but I did ask if you guys have any more questions, leave them now below and let us know if this was valuable. Did you enjoy seeing Walker dissect the answers? Let us know.
Yeah, what I would really like to know, we really went back and forth, like, man, should we really respond to one person in 4 or 5 different questions? And the value that we thought we could provide the community was overcoming the objections during a live stream. Jeffrey Schrader, has it been challenging working with an organization with niche products that reinforce their Industry 3.0 mindset? The answer is yes, Jeffrey, but here's how we go around that. even the organization that has the niche products that only stands to reinforce their industry 3.0 mindset, right? We don't really have to worry about competition. We don't really have to worry about competition because we're in a niche. Even those organizations are generally, there's some vertical within the business that isn't niche. And what you want to try to do,
like logistics maybe or something.
right? And what you want to do is you want to focus on transforming that non-niche sector. I would love to too. I'd love to invite. In fact, why doesn't somebody reach out to him, to Mark, and ask him if he wants.
I was
to be on
gonna
a
say, I
podcast?
mean, it was kind of just weird because like his comments kind of come from a place that seems almost a little bit triggered. Because I was gonna ask him like, why is he like defending his? I don't know. You know what I'm saying? But
Well,
no, what I
the
would like to
reason
say, yeah,
listen, if let's say you're Mark McMillen, I've never met the guy, but I can already tell you what his personality is like and everything. There's a certain type of person who's really good at his job, at his type of job, right? And think about it. To be a great process controls engineer, you have to really have 3 core traits. Number 1, you got to be really good at analysis. Okay. Number 2, you have to believe in your ability. Okay. And number 3, you've got to be willing to piss people off. Okay. If he's going to be a successful process engineer or a process controls engineer, he can't spend all of his time trying to teach people or educate people on what he knows. Most of the time, what he has to do is know that he's right, push through, and convince them with results. Piss him off in the short term, and they'll forgive him with the results, right? Now, that is a huge strength in his role. But in other areas of the business, that is absolutely a weakness. That's absolutely a weakness, right? And so your team needs to be made up of Marks, right? But your team can't be all Marks, right? It can't be all Marks. And I'm using Mark metaphorically.
right. Well, and to your point, you said having that mindset, you're not going to lead to the point of chief strategy officer of digital transformation, clearly.
Correct. But you are going to be a damn good process control engineer. I mean, with his mentality, he's going to be an exceptional PCE, but he's not going to elevate to a chief technical officer because his view's narrow. But
yeah, and
yeah,
I do appreciate him watching our videos. Yeah. I mean, anyone that watches our videos, whether they agree or disagree, I appreciate, that's what we put it out there for. So
let's do Seahawks. Optimum best practice security topologies for what you're doing is still of interest to me. I'm not speaking that I doubt it is secure. Seahawks, what it basically boils down to is this. Edge driven means that all connections are instantiated from the device that you want to protect, right? The biggest risk you have in an organization is allowing some unpermitted device or unpermitted application to access a protected device, right? Well, the server client architecture or the poll response architecture, where the server is what is the thing that instantiates the connection to the device, well, that inherently creates the risk to those secure devices. So if what you do is you create a topology or you create an architecture where the secure device instantiates the connection, that is the PLC only connects, you set it up so that the PLC only communicates outward to the permitted server. Well, then you have mitigated the risk. You've mitigated that risk by saying, if in that case, I don't even have to have any inbound ports open, right? The secure device is going to be configured with the IP address or the host name of the server it's supposed to talk to. So unless somebody goes goes to the secure device and loads in a a piece of malware that makes it talk to a server it's not supposed to talking to, then there is no risk. And by the way, if they can get to your PLC and put a USB drive and load malware on there, you got bigger problems.
Yeah, exactly. Right.
Yep. Hopefully that answers the question. All right, guys. I appreciate everyone's time. Two pieces of feedback. I would love, agree, see my above comment on the data diode. Yes, Seahawks, I get this a lot, the data diode piece. Think of it this way. A data diode, edge-driven in practice has the same outcome as a data diode. That is, once the data gets past a certain point, it can't, there's no inbound, there's no port open in the reverse direction, right? The difference here is at that point, the data diode is the secure device itself. The second it transmits out, there's no inbound port to the devices. And Zach Vaughn, I'd like for you to follow up with everybody and make sure that this type of Q&A was of value.
Yeah. Thanks so much, everybody. We'll see you guys next week. Or no, we'll see you guys on the mentorship call this Friday. And if you're not a part of the mentorship program, there will be a link below to join the waiting list for mentorship. We're going to be opening up in June this year.
Fried Mark McMillen with Absolute. Hey, you guys stay on. I want to talk to you real quick.
Yep.
Thanks, guys. We'll see you. Bye.
Yep. See you guys.